This model will demonstrate how a country's resources determine its comparative advantage, which would lead to differences in autarky prices, will then finally lead to beneficial trade. We will assume that there are two countries in the world that produce two goods using two factors of production. So at times the Heckscher-Ohlin model is also referred to as the 2 by 2 by 2 model. Two countries, two goods, and two factors of production. Suppose the two factors of production that we are looking at are land and labor, price of labor, wage W, and the price of land, rental rate R. So for any given factor prices, in this case it's wage by rental ratio, for any given factor price, food uses relatively more land than cloth, then food is said to be land intensive. So it's not the absolute amount of land, but the ratio of land by labor that is used in the food sector compared to the land by labor ratio that is used in the cloth sector. So it is possible that cloth uses relatively more land and more labor compared to food, but the land by labor ratio is less for the cloth sector than for the food sector. The term abundance is used when we are referring to countries. Suppose there are two countries, country A and country B, and if you look at their resources, land and labor, if the land by labor ratio for a country is higher than the land by labor ratio for the other country, this should be A, then country A is said to be land abundant. Okay? So for goods, the term used is intensity, and for countries, we use the term abundance. Right? So let's now set up this model, and we are assuming that there are two goods, cloth and food. Two goods are being produced, cloth and food, using two resources or inputs or factors of production. All these terms are used, and these are labor and land. Okay. We further assume, which is not too crazy, that food production is land intensive and cloth is labor intensive in both the countries, and that there is perfect competition in all the markets. Okay. So we have two countries, the home country and the foreign country. So since there is perfect competition in all the markets, this condition would have to be satisfied, which is price that you pay a factor of production or input. In this case, we are looking at labor. So the wage that you pay labor should be equal to the value that it adds to the output, or value of marginal productivity of labor. Okay, so these are the assumptions of our model. Home country right now is a closed economy, and there are two resources, as we know, labor and land. And we'll assume that labor and land are mobile across sectors, cloth and food. Also, that countries' resources are scarce. That means there is a limited supply of labor and land. Okay, so let's go ahead and look at the big picture, how we plan to set up this model. Okay, now we need to arrive at this point. We need to finally reach and explain what the equilibrium would be for the home country. And then we will introduce the foreign country, which would be similar to the home country in all aspects except for resources. So we'll assume that there are resource differences across the two countries, and we're going to go ahead and assume that the home country is land abundant and foreign country is labor abundant. Yeah? Other than that, there are no differences across the two countries. So all the demand conditions are the same, preferences are the same. So really, and the only difference is in terms of resources or inputs. So really, when we are trying to set up this model to reach the home country equilibrium, there isn't much happening as far as the consumption side is concerned. Yeah? All the play in this model is coming in the production side of things, because it's the input, differences in input, that is going to lead to differences in prices, autarky prices for the two countries, which will then lead to trade. So you're going to spend time, as we did in the case of the Ricardian model, setting up the production side of things, because that's what's going to be different across these two countries. Okay? And we're just going to assume consumption, certain preferences which are same for the two countries, and we're going to just superimpose a relative demand function on our final model. Yeah? So it's the production side that we would be spending time on. So this is how we are defining the production process. So let's look at the production of food, one of the goods. There are two axes, and we measure the two inputs on these two axes. And this curve represents the output that is produced of food. So all the points on this curve, these points, represent mix of the two inputs that can be used to produce this amount of food. Let's try this for 2 kgs. Suppose the producer is trying to produce 2 kgs of food. Okay? It can either use, at this point, 5 units of land and 3 units of labor to produce 2 kgs of food, or it can use 3 units of land up here and 4 units of labor. So this curve that we're looking at for 2 kgs, it represents or traces all combinations of the two inputs that can produce 2 kgs of food. Yeah. So what we are saying is that there is flexibility in how much land over labor ratio that is used in the food sector for its production. Yeah. Now, this flexibility did not exist in the case of the Ricardian model, right? We assumed that the unit labor requirements were fixed. In this case, we are assuming there is flexibility in the use of the resources. Now, let's look at this line here, increase in output. What is the slope of this line? Well, rise over run. So you have land and labor input, and the slope here is rise over run, 3 over 4 is 3 by 4. So that is the land by labor ratio if the producer is using land by labor and is following this line, right? Now, as you move away from this origin, there's an increase in output, which makes sense because the more inputs you use, the more land and labor you use, the more food you would be producing. Yeah. So the further away you are from the origin, more output is produced of food. And this line represents the T by L ratio, the land by labor ratio that is used by the producers. Now, if there is a change in factor prices, let's say the wage by rental ratio increases, that means labor becomes relatively more expensive. In that case, the producers might want to substitute away from labor towards land. So instead of using 3 units of land and 4 units of labor, they might decide to use 5 units of land and 3 units of labor and produce the same amount of output they produced earlier. Yeah? So in that case, they have changed the land by labor ratio they used to produce food. So you will have another line that is going through that point, and this then represents the optimum land by labor ratio that is used by the food sector. Yeah. And again, the slope is the T by L ratio. And the further away you are from the origin, more food is being produced. So this is how we define the production process. And these are very similar to your indifference curves. Yeah? These curves, because they are giving us combination of the two inputs that produces the same level of output. All right, so this is our production process. Now, with this production process for both sectors, this would be true for food sector as well as the cloth sector. In order to solve this problem, we are going to think about two relationships. We want to know how, when wage by rental ratios change, the two sectors would change the land by labor ratio that they use to produce the good. So we want to do this both for the cloth sector as well as for the food sector. Yeah. So we saw in the earlier graph that if there is an increase in wage by rental ratio, that means labor becomes more expensive, both the cloth and the food sector are going to hire less labor, which has become more expensive now, and more of land to produce the same unit of output. And so what happens to land by labor? Well, it's going to increase. So the two variables in this case are positively correlated. Yeah? The other relationship that we are going to derive is the relation between wage by rental ratio, so these are factor prices, and goods prices, relative price of cloth. Okay, so let's look at the first one right now. Again, factor intensity and factor prices. Okay. On the y-axis we have wage by rental ratio, and on the x-axis we have land by labor ratio. So we've already discussed that this is going to be a positive relationship. So if there's an increase in wage by rental ratio, there is going to be increase in land by labor. And let's draw this line for the cloth sector, and I'm going to give this line a name. so that I can refer back to this graph, and I'm going to refer to this as the CC line. Okay, it's just a name. I could have called this anything. And so we realize that this is for the cloth sector. Now we need to draw another line, and this time for the food sector. Yeah? But before we draw that line, we need to make sure that we are satisfying all the assumptions that we had made earlier while setting up this model. The specific one that we need to be concerned about here is the factor intensity. Yeah? We assume that the food sector was relatively more land intensive than the cloth sector. And how did we define factor intensity? Well, it was that for a given wage by rental ratio, when W by R is fixed, we observe that the land by labor ratio used in the food sector is higher than the land by labor ratio used in the cloth sector. So for a given W by R, wage by rental ratio, this is the amount of land by labor ratio that is used in the cloth sector. And so for the same wage by rental ratio, let's say this W by R is 5. So for the same W by R, the land by labor ratio for cloth is here. For food, it should be higher. So the land by labor ratio for the food sector should be somewhere here, right? So basically what we are saying is that the food line should lie on the right hand side of the cloth line. And if we did that, then for the same wage by rental ratio, we would have that the food is more land intensive than cloth. All right. So let's do that. Let's draw the food line, and we have food line which we are going to name FF. And here we have the first graph that we wanted to draw. Okay? And we can double check that at a given wage by rental ratio, let's assume it's 1, we have land by labor ratio for cloth. I'm just giving it some numbers. You could have assumed this is 3, just to bring the point home. And land by labor ratio for food is 3. So food is relatively more land intensive than cloth for a given wage by rental ratio. So our assumption of the model is satisfied here. So the second relationship that we wanted to define was between goods prices, which is price of cloth over price of food, and the factor prices, which is wage by rental ratio. And now let's assume that there's an increase in W by R. Wage is the price of labor, yeah? And labor is used in the production of both the goods. An increase in cost of production of the two goods. Price of cloth and price of food would rise. There's an increase in cost of production because of increase in price of labor. Given that food is land intensive, yeah, T by L is higher for food, that if you look at labor ratio, it is higher for the cloth sector. Yeah? So cloth is labor intensive. Cloth uses a higher proportion of labor. Since it uses higher proportion of labor compared to food, the price of cloth is going to rise more than the price of food. As wage by R increases, the relative price of cloth is going to increase as well. So what we have is a positive relationship. Okay? On the y-axis, we have PC by PF. On the x-axis, W by R. Yeah? Now, the two graphs have a variable that is common, wage by rental ratio. So how about we share this axis? Turn our first graph such that the two graphs have the same y-axis, which measures W by R. Why are we doing that? In the same graph, we can then answer how that changes land by labor ratio for the two sectors. Okay, so let's do that. We are adjusting our first graph such that on the y-axis we measure W by R. And so, I generally refer to these as the two quadrants. This is the first quadrant, and this is the second quadrant. All right. So let's just look at how these graphs function.